Hey guys. All right, so in this video, we're just going to look at factoring with a negative leading coefficient. There's a couple of different ways that you can handle that. So the problem that we're going to look at is negative 3x squared plus 17x minus 20. Okay, so when we're factoring this one, since there's a negative 3 right here, the first thing we would want to check and see if we can factor out that negative 3, right? But like the other ones, we have a problem because the 17 is not divisible by 3 and neither is the 20. But if we know that negative 3 is really just negative 1 times 3, what we can start by doing is factoring out a negative 1. Now that's still going to leave us with a leading coefficient there, but it does get rid of the negative problem. So we're going to factor a negative 1 out. So I'm going to put negative 1 and then parentheses, and everything here is just getting divided by that negative 1. So that's going to leave me with 3x squared minus 17x plus 20, right? We just divided everything by negative 1. Okay, so now I'm going to focus on what's inside the parentheses there, and I'm going to factor this. So when I'm factoring just this, now I'm going to treat it like the problems we were looking at in the first video, where we're going to take the 3 and the 20 and multiply them together. Okay, so 3 times 20 gives me 60. 60, let's see, what are our factors of 60? That's a 15 there if you can't read that. 5 and 12, 6 and 10, 11, and then we're back at 12. Okay, so if these are all my factors of 60, remember we're looking for a pair that's going to combine to give me a negative 17. Okay, so if I want a negative 17, the first one that I see here is the 3 and 20, right? If this is a positive 3 and this is a negative 20, that would make a negative 17. But when I look a little bit further down the list, I also have a 5 and a 12. And 5 and 12 can make negative 17 if both the 5 and the 12 are negative numbers. So since I have two options here, there are two possibilities. I need to make sure that they both still multiply to give me 60, right? It was positive 3 times positive 20, so this is a positive 60. Well, if I use the 3 and the negative 20, 3 times negative 20 gives me negative 60, not positive 60, okay? So this one is not going to work. If I use the negative 5 and the negative 12, that will still multiply to give me the positive 60, right? Because it's two negatives. So if you have two different choices like this, you want to make sure that it both combines, it adds to make this number, but it also needs to multiply to make this number, okay? And that's where the x that you guys learned last year would come in handy. All right, so now that I know which pair of numbers I'm using, I'm going to go ahead and set up the box here. I've got 3x squared in the first box, positive 20 for the last box, and then I'm going to use the negative 5x and the negative 12x. And now it is just like the previous problems where we're going to factor out the greatest common factor for each row and each column. Okay, so for each row across the top here, the only thing I can take out is an x. Across the bottom here, the only thing that I can take out is, well, let's see, this is a negative 12, and this is a positive 20, so that's what, a greatest common factor of 4, and since it's touching the negative 12, I'm going to make it a negative 4. Okay, then for the columns, right, I've got 3 and 12, so we can take a 3 out. They also both contain an x, so let's pull out an x. Here I have a negative 5, right? Because it's touching this negative 5, and 5 will go into both 5 and 20. Okay, so this is 3x minus 5 and x minus 4, but don't forget, we still have this negative 1 hanging on in front. Okay. All right, so when we're factoring, when you have that leading coefficient, if it's a negative number, see if you can factor out the whole number, and if not, just factor out a -1. And then you can factor what's left like normal. Okay. All right, there were just a couple of special cases that I wanted to kind of look at with you guys, and those were the difference of squares and the perfect squares. For the difference of squares, you can factor them just like we did these problems, and I'll show you guys that. But if we recognize difference of squares when we see them, there's actually a shorter way that we can do it, okay? So when I'm starting out with a difference of squares, if I just start out with something like x squared minus 36, that is a difference of squares. Okay. Now, we could expand this. You might notice that this is missing a piece, right? Normally we have a middle term that just has an x in it. Well, if we expand this out to include that term, this is x squared plus 0x minus 36, right? Because there's no x term, so that means there's 0 x's in the problem. All right, so if I try to factor this like normal, right? This one's kind of nice because there's no leading coefficient there. I'm looking for factors of 36 that are going to combine to give me 0. So I'm going to make a list of my factors of 36. All right, there's all my factors. Well, the only pair that can combine to give me 0 would be 6 and 6, right? 6 times 6 is 36 because 36 is a square number, right? Okay, so then the only way the 6 and the 6 can combine to make a 0 is if one 6 is negative and one 6 is positive. And that's okay because this was a minus 36, which means we're actually trying to make them multiply to make a negative 36. So negative 6 times 6 is negative 36. And if I add negative 6 and 6, it does make 0. So for this one, since I didn't have a leading coefficient, I don't have to use the box method here. I have x minus 6 and then x plus 6. This is a difference of squares because the only difference is one's a minus sign and one is a plus sign. Okay, so now that we've seen kind of the longer way to do that, here's the shorter way we can get there. If I recognize from the very beginning of this problem that this is a difference of squares, right? What we're really just doing is the square root of the first term and then the square root of the last term. The square root of x squared is x. The square root of 36 is 6. And if I know it's a difference of squares, it's going to be x minus 6 and then x plus 6. Okay, so for example, if we did x squared minus 64, let's do this one the short way. If I take the square root of both, I have x and 8. So since I know this is a difference of squares, it's x minus 8 times x plus 8. And if I want to double check myself, I can always FOIL and see that it reduces back to my original problem, x squared minus 64. X times x is x squared plus 8x minus 8x minus 64. We'll combine those like terms, and there's our x squared minus 64. Okay? All right, so those are difference of squares. If we have one that has a leading coefficient, let's say 9x squared minus 16. Well, we can still start by doing the 9 times 16, and that's going to give me, we should start by writing it as 9x squared plus 0x minus 16. All right, so if we're doing this one the long way, we would do 9 times 16 to get 144. Okay, so then if I have 144, the factors of 144, I'll make that list real quick. Ooh, finally. A lot of factors for 144. Ooh, went off the screen. Okay, so these are my factors for 144. Remember, we're looking for the pair that's going to combine to give us 0. Well, that's going to be 12 and 12, right? Square root of 144 is 12. So if we use the box method here, right, one of the 12s has to be negative and one has to be positive, and that's okay because our 144 actually was a negative 144, right? 9 times negative 16 for the negative 144. Everything checks out here. But since this one has a leading coefficient, we do need to use the box method. So if I set up the box here, I've got my 9x squared and then my negative 16. I've got my negative 12x and my positive 12x. I'm going to factor out for each row and each column. Okay, and I got 3x minus 4 times 3x plus 4. But even though it had that leading coefficient, this was the long way to work this problem, okay? The short way, just like we did on the other problems when there was no leading coefficient, as long as it's a difference of squares, okay? So as long as there's no middle term right here, we can do the square root of the first term and the square root of the last term. Well, the square root of 9 is 3. X squared, when we square root it, just leaves us with x. The square root of 16 is 4. And if I recognize it's that difference of squares, 3x minus 4 times 3x plus 4, just like we had before. Okay. Okay. Now a perfect square then is going to look a little bit different. So a perfect square might look something like x squared plus 4x plus 2. They're a little bit more difficult to recognize. And so often we just factor those normally. But if I know, nope, that should not be a 4 right there. I'm sorry. That should be a 4. There we go. Okay, so if we recognize those, if we factor this out, right, now that it's x squared plus 4x plus 4, then when I start looking for my factors of 4, right, I've got 1 and 4, I've got 2 and 2. The ones that will combine to give me a positive 4 are 2 and 2. Okay, so that means I'm going to have x plus 2 times x plus 2. Well, if it's x plus 2 times itself, we can also write that as x plus 2 squared. Either one of these would be fine, okay? But that's why we call it a perfect square. Another example would be if I had like x squared plus 8x plus 16. Right, this one is also going to be a perfect square. When I start looking for those factors of 16, I've got 1 and 16, 2 and 8, but then I also have 4 and 4, right? So this is going to be x plus 4 times x plus 4, or we could write that as x plus 4 squared. Okay. All right, I hope this has been helpful. As always, let me know if you have other questions or if there's anything else that I can help you guys out with. And then let me see if I can find my mouse to stop this. Okay, we will Zoom on Wednesday. Geometry, we will Zoom at 2. Okay, so if you got questions, Zoom at 2 on Wednesday.